Hello everyone, welcome to Skills Build Training YouTube channel. Myself Mohammad Zubair, and this channel is all about showing you how to become an IT pro really fast. So the topic of today's video is TCP versus UDP comparison. So without any further ado, let's get started. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. Both these protocols work on the transport layer in OSI model, and transport layer uses both of them depending on the type of data to be sent over the network. If you want to know more about OSI model and OSI layers, we have a video on our channel. I have added a link in the description as well, so do check that video. First of all, let's understand the working of each protocol and why and where each gets used. TCP is used when we do not want any interruption and any latency in our data. Data delivery is our optimal goal, because whenever data gets sent over the network by TCP, it keeps track of the data which gets sent over the network. As you know, the data gets transferred as small chunks into the network. Let's say data was being sent and certainly there was some problem, and because of that the data transfer gets affected. In that case, you do not have to send the whole data again. TCP will only send the data again which got lost during the transmission. And because of this feature, network do not have to use a lot of resources. And as we are only resending the data which got lost, network also needs less time to complete the operation. Once the data gets to the receiver end, the receiver starts to reassemble the data in the same order in which it was divided into small chunks. And to do this, sender attaches a sequence number with every chunk of data, and receiver uses that sequence number to reassemble the data on its end. And this is how reliable delivery of data takes place using the TCP. Before starting to send the data over the network, a three-way handshake takes place between the sender and the receiver. In first step, synchronization request gets sent to the receiver from the sender, and receiver sends back the acknowledgement letting the sender know that it is ready for the communication and for receiving the data. Along with acknowledgement, it also sends the synchronization request to sender. And in the final step, the sender sends back the acknowledgement to the receiver. So that was all about how TCP works. Now let's talk about UDP. If we talk about the UDP, it is a connectionless and unreliable protocol. It is used for broadcast and multicast type of communications. UDP is used when we can afford latency and data loss. And we also use UDP when we need to send small amount of data. For example, when we do video or audio conferencing, it usually takes place over the UDP. UDP does not care about the data loss as TCP does. It just keeps firing the data, and that is why when we are on our video or audio conference, we experience latency in our transmission, because some of the data keeps on losing during the transmission, but we never lose our connection. This is because of the ability of UDP to work on less bandwidth and internet speed. And there is no need to send the data again over the UDP. And that is why there is no concept of acknowledgement in UDP. In TCP, when we send the data, the receiver sends the acknowledgement to the sender, and that is how we get the reliable data delivery in TCP. But as there is no acknowledgement in UDP, so that is why there is no data reliability, and this is why UDP is also known as one-directional connection. So that was all about the brief working and use of both protocols. And now let's have a comparison of both protocols on the base of some common features. If we talk about data sequencing, TCP has the ability to sequence the data, and only because of that we get to receive the same data which gets sent over the network to us. But UDP does not have the ability to sequence the data. That is why it is used where we can afford the data latency and data loss. In terms of retransmission of data, in TCP, if data gets lost, the data is retransmitted, and because of that, we get the reliable delivery of data. In UDP, there is no such thing like retransmission of data. It just keeps firing the data and not bothered about if it is getting lost or not. Next feature is speed. TCP is bit slower than UDP. As we know, it allows the retransmission of data, and obviously it takes time to retransmit it, and that is why it is bit slower than the UDP. And obviously TCP is a bidirectional connection or bidirectional communication. That is one more reason why TCP is slower. If we talk about UDP, it is faster than TCP, as it does not have to retransmit the data again and again in case of a data loss. That is why it is faster than TCP. And we also send the small amount of data with the help of UDP. That is another reason it has high speed. If we talk about the usage, TCP is used by HTTP, FTP, SMTP and Talent, etc. UDP is used by DNS, TFTP, SNMP, DHCP, NRIP, etc. If we talk about the error checking ability, TCP provides the error checking with the help of acknowledgements and checksum, and it has extensive error checking phenomena. And this is why we get the reliable data delivery. In UDP, we do have error checking mechanism, but it is not as extensive as TCP. If we talk about connection, TCP requires to have established connection for data delivery, and that connection needs to be closed when data transfer gets completed. But in UDP, it does not require an established connection. If we talk about the application of both these protocols, TCP is used by the systems and applications which are not time sensitive. But UDP is used where time sensitivity is the issue, and it gets used where we have to answer small queries in bulk. For example, if you want to send a file through email, you can afford late delivery, but you cannot compromise on reliability of your data or your file. That is why we use TCP. But let's say you want to communicate over audio or video conference. You can afford data latency, but you cannot afford late delivery of your data. That is why we use UDP in audio and video conferencing. So that was all about the comparison of both these protocols on the basis of some common features. And at the end, I will talk about one very important aspect of both these protocols, and that is the headers. As you can see on your screen, we have the header of our TCP. First, we have source port, then we have destination port, and then we get sequence number. As I have told you that we use sequence number to reassemble the data, and then we have acknowledgement number. And here we have some header length, and then we have some reserved bits, and they are usually the size of 6 bits. And here we have some flags, and each flag have 1 bit of space. Here we have some information about Windows, then we have checksum, then we have urgent pointer, and this portion is optional. And here we can have the size from 0 to 40 bytes. If we talk about the size of each section, source port and destination port each consist of 16 bits. In total, it has the 32-bit size or 4 byte. Sequence number also has 32 bits, which means 4 bytes. Acknowledgement has 32 bits, and then in this section we have 32 bits in total. Same goes for checksum and urgent pointer, which consist of 16 bits each and 4 bytes in total. So in whole, we get 20 bytes of size for our TCP header. And down here in optional section, as I have told you earlier, we can have from 0 to 40 bytes. So in total, we can have minimum of 20 and maximum of 60 byte of header size. And header size plus the data which gets sent over the network is called segment. In simple word, this all information gets added with every chunk of data while we transfer it over the network. So basically, the data which gets sent is called segment, And one segment is composed of all this header information, which can be 20 to 60 bytes, and the amount of data which is being sent. So basically, we have two things, the header information and the data. Now let's talk about the header of UDP. In UDP header, we only have 4 parts. First one is source port, then we have destination port, then we have length, and at the end, we have checksum. And that is why we only get limited error checking in UDP, as we only have checksum in it. But in TCP, we have acknowledgement as well. So in total, UDP consists of or composed of 8 bytes in total. It means the size of UDP header is 8 bytes. So that was all about the UDP header, and with that, we get to the end of today's video. So I hope I was able to make you understand and differentiate between TCP and UDP. If that is the case, please leave a like and subscribe to our channel and press the bell icon along with it. If you have something to ask, please leave a comment below. We will get back to you as soon as possible. Till the next video, take care.